Hey guys, we're going to continue our factoring unit today with a special case for a quadratic function, which is called a difference of squares. So if I have two squares I'm subtracting, and there's a special rule that goes along with that. So I'm going to give you a couple of examples to discover that rule, so that way you have it and you can use it. So we're going to start with a pretty simple quadratic function, just x squared minus 25. Okay, so what we're going to do is we are going to factor this just like we would a usual quadratic using our error model and our X games. But what you'll see is, like I said earlier, that there's a rule that kind of comes from this. So the reason we call this a difference of perfect squares is because x squared is a perfect square. It's the perfect square of x. X times x is x squared. Anything times itself is a perfect square. 25 is a perfect square. 5 times 5, 25. And being the fact that this is being subtracted, I have a difference of two perfect squares. So what we're going to do is we are going to create our area model just like we would with any type of quadratic function that we are trying to factor, and our x games. Okay, so just like usual, our first term, always that x squared term, always goes in that upper left hand corner section of my area model. Okay, my constant value, okay, which is my last term, okay, always goes in the lower right hand corner, and again that's the constant value. Okay, what you'll notice is that there is no x term, there is no middle term. Okay, however, that then tells us that I need 0 x's to add inside of my area model, right? So I need these two boxes, these two parts of my area model to cancel out, so that way I end up with 0. Okay, just like we did before, I take my first area and my last area, I multiply them together, so I need negative 25x squared. So that's what I need to multiply to get. So I need to multiply to get to negative 25x squared and add to get 0x. Okay, so I'm looking for factors of 25. Okay, and because it's negative, that means one has to be negative and one has to be positive. Well, there's only two sets of factors of 25, 1 and 25, and 5 and 5. Okay, and what you'll notice is that 5 and 5, if one of them is positive and one of them is negative, in order to get a negative 25x squared, when I add 5 and negative 5, I also get 0. Okay, so that is my set of factors, so I know that negative 5x goes in one, 5x goes in the other, and then we find our outside pieces using our greatest common factor, just like we did in last week's videos. So the greatest common factor for here between x squared and 5x is just an x. The greatest common factor between x squared and negative 5x going this way is also the x. And then we can kind of just fill in them from there. What times x gives me negative 5x is a negative 5. And what times 5x gives me, or what times x gives me 5x is a positive 5. Positive 5 and negative 5 give me a positive 25. So when I factor out x squared minus 25, I get x plus 5 and x minus 5. Okay, so there's your first example. Okay, our second example, okay, still a difference of perfect squares, so 9x squared minus 16. Okay, 16 everybody knows is a perfect square of 4 times 4. Okay, 9x squared is a little bit different, but it kind of works the same way. 9 is a perfect square of 3. X squared is a perfect square of x, so 9x squared is a perfect square of 3x. So if I take 3x times 3x, any number times itself is a perfect square. It gives me 9x squared. Okay, so we're going to do the same thing. We're going to build using the area model and our x games. So 9x squared goes in my first piece of my area model. Negative 16 goes in my last. Because I'm missing that middle term, I know that 0x is what I need. So I need my two factors, whatever they are, to cancel out. What you notice on this first one, in order for them to cancel out, they have to be the same number. One's positive and one is negative. The question is what is that number? And so I'm looking up here, and that number comes from multiplying 9x squared times negative 16, which is negative 144x squared. Okay. Well, there are a lot of factors of 144x squared, but because we kind of have an idea of the fact that I need these two pieces of my area to be the same but opposite sign, Okay, I'm asking myself what number times itself gives me negative 144, or positive 144. One would be positive and one would be negative. And for those of you that know your perfect squares that high, it's 12 and negative 12. 12 times 12 is 144, but one needs to be positive and one needs to be negative. So I know that 12x goes in one piece, or one of my pieces, missing pieces, negative 12x goes in the other. And then again, we're looking for greatest common factors. So greatest common factor for this piece right here, between 9x squared and negative 12x, is a 3x. Well, if this is 3x, this also has to be 3x up here, because 3x times 3x is 9x, which is the GCF, the greatest common factor between 12x and 9x squared. And then I can fill in the rest of the pieces. 3x times what gives me negative 12x? Well, that's a negative 4, which is also the greatest common factor between negative 16 and negative 12x. And then what times 3x gives me 12x is a positive 4x. So I know that 9x squared minus 16 is equal to 3x minus 4 times 3x plus 5. Okay. Let's do one more example here, and then we'll kind of talk about what patterns we see. So the third and final example I have for you is 64x squared minus 9. Again, to find the pattern, we're going to use the area model and X games. So 64x squared goes in the upper left corner, negative 9 it goes in the bottom right corner. I have 0 x's in this equation. Middle term is not there. And then if I take 64 times 9, I get negative 576x squared is what I need. Now, for most people, really 15 squared is about the highest that you need to be able to know the square root of. Okay, so 576, what times itself is 576, is not necessarily one that a lot of people know right off the top of their head. But if you kind of work your way through and kind of guess and check if you don't know, you'll come out with 24 and negative 24 as being your number, your numerical value to multiply by itself to get to the 576. So 24x and negative 24x go inside my area model. Again, we want these two pieces of my area to add together to get me the 0x, because there's no x's in there, but they're still part of the area model. Again, if we then go through finding our GCFs to find these first two pieces, the GCF here is 8x and 8x in both directions. Okay, so then 8 times what gives me 24? Well, that's a positive 3. 8x times what gives me negative 24x? Well, that's a negative 3. So what that tells me is 64x squared minus 9 factors to equal 8x minus 3 and 8x plus 3. Okay, so now that we have our three examples done, what you'll notice hopefully is a little bit of a pattern. Okay, like we started off with, each of these, now 6 terms, are perfect squares, right? X squared is x times x. 25 is 5 times 5. 9x squared is 3x times 3x. 16 is 4 times 4, which just makes me feel like I made a really quick mistake here. That should be 3x plus 4. Sorry about that. 64x squared is 8x times 8x, and 9 is 3 times 3. Well, what you'll notice is for x squared, x times x, that's the first term. Each of those is an x and an x, and the 25 is a 5 and a 5, right? So those squares, okay, the values of those squares, so the square root of 9x squared is 3x, well, that's the first term, and the square root of 16 is 4, which is the second term, and that is true in all of these cases. And so our rule is for the difference of perfect squares, and this only works for the difference of perfect squares when it's a subtraction symbol. Okay, if I have any general equation, and we're going to use a's and b's, so if I have a squared minus b squared, it's a difference of two squares. Okay, so a squared and b squared. Okay, I take the square root of each of those numbers, so the square root of a squared is a, and the square root of b is b. I add them, so a plus b, and I subtract them, a minus b, to get my answer. Okay, so let's do one more using our rule here, okay, without using our area model. So if I have an equation that looks something like this, let's say 49x squared minus 36. Okay, so we notice that 49 is a perfect square, 7 times 7. X squared is a perfect square, x times x. So 49x squared is 7x times 7x. And 36 is a 6 times 6. I can use my rule. So the square root of 49x is 7x. So I know it's going to be 7x plus something and 7x minus something. And that something is, well, what's the square root of 36? 6 and 6. So 6 and 6. So if I take 49x squared minus 36 and I were to use the area model in the x games, I'm going to get 7x plus 6 and 7x minus 6.